So today's topic we have chosen is on hangers and support solutions, and we will also touch seismic applications. Since it is a very popular topic, we are currently running a repeat session. We had the first session on Monday, and after 2 days, we planned that maybe some of you missed or you were really busy in your schedule. So we don't want to miss your presence in any of our webinars. So we are doing it the second time. So here is what we would cover today. We would go with introduction. We would touch the major design codes used for support of MEP services. We would also show you some case studies. I would take you through some application examples. We would discuss in detail about seismic solutions. And of course, last but not least, we will have a question and discussions time. Before we begin, I would like to introduce myself. My name is Tinu Thomas. I work as Technical Manager for Fischer in UAE. I will be available for you for a chat today under the user ID Tino Thomas. And if in case you have any technical problems, my colleague Marsook would be available under the user ID Fischer MEA. The duration of the webinar is 45 minutes, followed by a 10-minute question and answer session, followed by a feedback session of 5 minutes. So we hope that we would be precise on time and we can finish the webinar by exactly 4:30 p.m. Some tips for an improved webinar experience. We recommend to use only Google Chrome, if not Firefox. Try not to use Internet Explorer as we had some issues in the past. Please try to avoid any parallel downloads because this is a streaming service. So if you have a heavy download, it might hinder the connection and it might spoil your experience. Questions are very important. Questions are a proof of interaction in a webinar. So we would love to answer all your questions. If in case during the presentation I missed to answer any of your questions, I would definitely try to reply back after the end of the webinar. And if in case we run out of time, I would make sure that you would get all the answers emailed. So I hope all of you would be having a screen similar to what you see now. So first things first, please go to the full screen button and press so that you would see the webinar in full screen, because some letters, some pictures might appear to be small if you have not activated the full screen button. We have a chat window anytime during the webinar. You can feel free to chat with me or Marsook. If you face any trouble in your system while you try to attend, please, you can post your concerns in the chat window. You can also see a questions button. Please go to the questions button to post all your questions. Avoid posting questions in the chat window because in chat we will have a lot of messages, good morning messages, hi, hello messages, goodbye messages. In between, maybe your important question might get lost. So we would recommend that please post your questions in the questions tab. Last but not least is the poll. Poll is a feedback. So we would love to get your feedback, good or bad. So this helps us to improve our webinar and future sessions with you. So please, we request to do not leave before you give us your rating under the poll screen. Fischer as a brand is a very famous German multinational organization founded in 1948, which means we are more than 65 years young as a company. It is headquartered in Waldachtal in Germany, near the Black Forest area. We have around 46 subsidiaries, which means 46 branches around the world which are directly owned by Fischer. Our products are getting distributed to more than 100 countries worldwide, and I am a part of more than 4,600 global employees of Fischer working everywhere around the globe. We have around 1,500 international patents, which is what we are always proud of, and we produce more than 14,000 articles every single day. Without any further delay, I would go through the codes. The first code which comes to my mind when I talk about MEP is regarding firefighting. Firefighting is one of the most critical aspects in an MEP because it is related to fire and safety. So the most important prevalent code which talks about firefighting pipes is the NFPA, and in particular NFPA 13. Uh, can I can I have a reply? What does NFPA stands for? NFPA. Okay, no problem. I will go ahead. I'm getting a reply. Yes, National Fire Protection Association. Thank you, Mr. Ramesh. You're absolutely right. NFPA stands for National Fire Protection Association, out of which NFPA 13 stands for Standard of for Installation of Sprinkler Systems. I have another question. What is the safety factor to be considered while designing of firefighting pipe supports? I repeat, what shall be the safety factor to be considered while designing of firefighting pipe support? Let's say we are designing a firefighting pipe to be supported. The size of the pipe is 4 inch. The weight of water pipe filled with water is 50 kg per meter. How much shall be the safety factor to be considered? I have options. We should consider 1.5 times weight of pipe with water, 2 times weight of pipe with water, 5 times weight of pipe with water, 5 times weight of pipe plus 114 kgs. So, what do you think? A, B, C, or D? Which is a correct answer? Thank you, Mr. Shuraim. Thank you, Mr. Muhammad. So Mr. Shuraim says 1.5 times, which is option A, and Mr. Muhammad says option D, which is 5 times weight plus 114 kgs. Mr. Shafin says C, which is 5 times weight of water. Dipankar says National Fire Protection Association. Yes, you're right. Ishaq Ali says option C, which is 5 times weight of pipe with water. Okay, great. Thank you very much for actively participating. We would see what the result is. So the main factor to consider on NFPA affecting the design of hanging bracing and restraint pipes is, is point number 1. All hangers shall be designed to support 5 times the weight of water filled pipe plus 250 lb or 114 kgs at each point of piping support. So the correct answer, if you go back, is option D. Do we have an option D? Yes, Mr. Muhammad Ziauddin Ahmad. You are absolutely correct. The answer is option D. Now, apart from this, there is also a main codal provision which states that the spacing between hangers shall not exceed the value given for the type of pipe as indicated in the table. So which means if we use a very strong support which can carry the pipe up to 10 meters, but if in case in the table the distance between pipe support mentioned to be only 3 meters, then 3 meters it should be. You cannot increase the spacing between supports more than table 9.2.1a. Third most important point is detailed calculations shall be submitted when required by the reviewing authority. Now the reviewing authority could be civil defense, it could be an on-site job consultant to show that the support has been calculated and it is proven to take the weight of the pipe, including all relevant safety factors mentioned in point number 1. These are some of the popular products used in firefighting applications. The first one are the clamps. We have two options here, a swivel clamp and a sprinkler clamp. These are, as you know, for horizontal pipes. For vertical pipes, you do have the riser clamp, and then we also have the anchors and threaded rods. Now, all clamps should have a UL or FM listing for firefighting applications. You would also need additional components in certain projects like a channel system. Sometimes you don't have concrete, so you don't need anchors, but you do have I-beams. So you need certain beam clamps to drop the threaded rod. You would also need sometimes to support the pipe from the wall, so hence you need wall-mounted supports. This is an example of a firefighting pipe supported from a wall or a steel wall using cantilever arm and a riser clamp. So this is basically a riser clamp holding the pipe at its place, and the riser clamp is supported from the wall using two cantilever arms. This is another example of a complex firefighting pipe support. You can see there are multiple firefighting pipes seen in the picture, and some of which are not coming directly below the steel structure itself. For example, here you have a firefighting pipe, but the steel beam is here and here. So in between, what do? We provide a secondary steel slotted channel, as you can see here, and from this slotted channel we drop the support. So sometimes things are not very simple, so we have to do custom engineering solutions which we are known to be best at. I would love to share one of our most interesting case studies. This is for a project in Abu Dhabi. It is for Presidential Flight Hangar 2. This project was completed in 2016. The contractor with whom we were associated was NAFCO, and the consultant was AECOM. The application was very simple. It is just to support firefighting pipe supports. But when we reached the site, this is what we had. We looked for ceiling and support locations from where we can drop our threaded rod to support the firefighting pipes, but we realized there is no concrete. There are some beams, I-beams and box beams, but they were all really far. And to make it worse, the pipe was not coming directly below these I-beams or box sections. So if you have a look at this picture, You can see you have a firefighting pipe, but the I-beam is not directly above the firefighting pipe. It is eccentric. There is a distance. So how do we do that? So then we brainstormed and we developed a solution, which is this. So the pipe is here. So we made a special custom frame to support pipe from the I-beams. So this picture might be able to give a better perspective for you. So as you can see, the I-beam is located away from the pipes. So we made a frame with an eccentricity so it can carry the weight of the pipe. These are some other mock-ups which we did in this project for multiple solutions. We had another challenge in this project. The second challenge was after the installation was complete, there was a requirement to do to support the pipes for seismic forces. So since the pipe supports have already been installed, the contractor did not want to remove the existing pipe, but he wanted to convert the existing normal support to a seismic support. And hence, we thought about a different solution. We thought about interconnecting three normal supports like this. What you see now is the plan drawing. So we connected support number 1, support number 2, and support number 3, so that in the event of an earthquake, they are all holding to each other, positive of this support to the negative of this support to the positive of this support. So it balances each other. So when you have an earthquake, the pipe will stay strong. To make this bracing or interconnection, we had to develop a new base plate or a special kind of arrangement, a flat plate, and then we did all the calculations, structural calculations, seismic calculations, and then finally we had the finished product at site. So as you can see, this is how we interconnected different supports to form a seismic support. This is a blowout picture of how it looks like. We had another challenge, which was to support firefighting pipe riser. But when we went to the riser location, we had a beam and in the top. There was nothing in between. So again, we had to go through a lot of brainstorming. We made a secondary steel column using our products, and a special assembly to support the risers was mounted to these columns to take the load. So thereby we solved that challenge. We also have various other challenges, like how do you run the support from the wall, and the wall sometimes were made of block masonry. It was not concrete. So we had to also develop custom cantilever arms from the wall to provide support of firefighting pipes. That was about firefighting. The next topic which we would see is HVAC, heating, ventilation and air conditioning. The most popular code in HVAC is SMACNA. Can you help me? What does SMACNA stand for? No problem. SMACNA stands for Sheet Metal and Air Conditioning Contractors National Association, again a body from US. Thank you, Mr. Ramesh. You're absolutely right. For HVAC service, basically we have two services to support. Number one is the duct. Number two are the chilled water pipes. These can be supported uh, in a riser as a vertical duct or a vertical pipe. It could be suspended from the ceiling or mounted on the floor. You could also have a requirement to provide seismic bracings to make the service safe even in the event of an earthquake. The main factor to consider on SMACNA affecting the design of ducts is the way the calculation needs to be carried out. As per SMACNA, it is said that the main weight of the duct should be applied in the middle, and then half of the weight left should be applied at the two corners where the duct is touching at the channel. So as per SMACNA, there is no uniform distributed load. There should be a main load in the middle of the channel and then two half loads at the corners to make the design a little more critical and to be on the safe side. So this is how a typical support for duct looks like. And we also have a drawing service. You can utilize our services for getting any detailed drawing. The common products which we use for HVAC contractors are channel system to support ducts, cable trays, beam clamps to support from the I-beams, and also drop-in anchors to support from the concrete ceilings. We also have special duct clamps which are circular, which are mainly designed for ventilation ducts which are circular in shape. In addition, we also have duct hangers, L and Z shape, to support the duct directly. These are for GI ducts, non-insulated. So it's very easy. You can directly rivet it to the duct and it can be connected directly to the threaded rod. Now, that was about products. I would like to talk more about solutions. So here we always think about solving problems at site. So this is a typical problem which we had in the past. We had to design duct and cable trays in a project. But upon receiving feedback from the site, this application was inside a very congested corridor, so they did not have enough space to give a separate support for duct and electrical. So we had to combine. Similarly, you can see on your right side, duct and small pipes we combine. So basically, we believe to solve these problems. So this is a typical support for duct. The vertical element could be threaded rod. It could sometimes be channel, depends on the requirement. And also we have all kinds of data sheets. This is from our catalog for easy calculation of stress on the channels. We also do detailed engineering calculations to prove that the supports are strong enough. Apart from ducts and chill water pipes, we also do calculations for supporting fan coil units, chiller units, risers. The next service is electrical services. So electrical services, mainly we are talking about cable ladders and cable tray support. Unlike HVAC and firefighting, there is no strict standards, though there is also a popular design code available which is called BEMA. BEMA is known as the best practice guide to cable ladder and cable tray systems, including channel support systems and associated supports. So here, as you can see in this picture, you are seeing a bus bar. So bus bar, on your left side, bus bar is going horizontally, and on your right side, bus bar is going inside a shaft vertically. So we design the supports for both the scenario. We have cable ladder supports, multiple cable ladder supports. What is the difference between a cable ladder and a normal cable tray? Why do you have to use a ladder instead of a cable tray? Any electrical contractor here? Any electrical engineers? Okay, so the answer is there obviously in the picture. Cable ladders are mainly used to carry high voltage cables which are heavier and which cannot be carried in a cable tray because the load itself is much higher. So we not only design a single cable ladder, we sometimes provide a rack solution as you can see on the right picture. Here you have a rack of more than 5 layers, and also we cannot ignore or move away from electrical services without mentioning cable trays. So yes, we also do the design calculations for normal cable trays, risers, and so on. Also, cable trunk is a main important application. These are comparatively lightweight applications carrying lighter cables, LV cables. So this also needs to be supported in a job site. In electrical department, also we have to fix a lot of panels. Now, how do you fix these panels? These panels could be wall mounted, sometimes it can be floor mounted, sometimes it is on top of a frame, on a pedestal, so multiple challenges could arise. For example, this is a wall mounted panel or a distribution box, let's say. It is mounted to this wall. Now, if this wall was made of AAC blocks, white blocks, autoclaved aerated concrete blocks, how would you connect this panel? Which anchor would you have used? Mr. Sachin, yes. So since you are from electrical, maybe you would have a better reply, or anyone from any other departments, because this is not related to electrical as such. What anchor do you use to fix this panel to an AAC wall, the white color block wall, which are very light? So how do you fix this dBs or SMDBs to such wall? Mr. Shuraim says it is an aircrete anchor. Any particular name or model which comes to your mind, Mr. Shuraim? Or from your experience, maybe you didn't use a Fischer product, but maybe you can talk about how you solved this challenge. How did you connect? Okay, AAC block is one of the most critical elements in the construction site because it is very weak, though it has got excellent thermal conductivity properties, thermal isolation properties. So it is very important to choose a right fixing. With us, we have a couple of options, like we have the FPXI, which is aircrete anchor, which can work fine in aerated blocks. We also have chemical anchor solutions, which can also be a problem solver in autoclaved aerated blocks. So I would like to share some common type of supports which you would encounter being an MEP contractor. So the first type of support is the wall-mounted cantilever support. This is when you require an MEP support from the wall. So as you can see here, sometimes you could have multiple pipes to be supported. Now this is another solution which is a wall-mounted cantilever with bracing. Now, the bracing is provided to give additional strength to the cantilever arm itself because we are supporting here two pipes which are filled with water, so hence the load would be on the higher side.
We have different kinds of supports as I discussed. So here is an example of a typical frame which is mounted from the ceiling. We also have a complex support where you need pipes to be supported in between two I-beams where you don't have any secondary steel layer. We add a secondary steel layer here to support the pipe. Now let's discuss about seismic. What is a seismic force? What in your opinion causes seismic? What is a seismic load? What comes to your mind when we talk about seismic? What could be the cause? Seismic is the irregular movement of the earth layers. As you can see, when the earth layers are moving, the ground shakes, the buildings, there will be a horizontal force, earthquakes, right? And then you would have a disaster. So during an earthquake, additional forces are applied to the building structure. So why is seismic design required? Do you think it is important to do seismic design of structural and non-structural components? What is the importance of this design? The first important parameter why we should consider a seismic design is that it is a protection for human life. Yes, Mr. Shuraim, it is a concern of safety. Yes, Sachin says capable to withstand earthquake. Yes, absolutely correct. So the first point is to protect our life. The second point is to limit the intensity of damage the earthquake can cause. The third is structures which are important, like imagine an earthquake and hospitals are all collapsed. So there are certain important structures which should work even in an earthquake. Even after an earthquake, these buildings should remain operational. So certain buildings, it is very important to withstand and sustain the effect of earthquake and continue working as normal. This is some information about the effect of seismic on a concrete structure. As you can see, these are the direction of various loads acting on a building structure. The main difference between static and seismic loads are static load means whatever load is there. For example, this is an equipment suspended from the ceiling. There is no movement or there is no inertia in a static load. So this is the case when you have a static load. But when you have a seismic load, the whole building moves, so the whole application, your equipment also moves, and thereby causing a huge inertia force on the application and thereby leading to the concrete. So basically, the mainly seismic force acts in horizontal direction. So if you have a tall building, chances are that the tall building can collapse down. Whereas if you have a massive building like a shopping mall, which is not higher, then chances are that the building itself can slide off during an earthquake. And it is also important to note that an application in a level 2 might not be as critical as an application in level 10. So if you have a table on second floor, table might move very less compared to a table in the roof. So as we just saw, seismic forces are always acting horizontally and not vertically. So it is very important to design the seismic support system accordingly. At Fischer, we focus on providing three main solutions. The first one is a rigid system, the second one is a rigid system with bracing, and the third one is a 100% complete bracing system. All three options are available based on site conditions, location, etc. So the first option is the rigid system. As you can see, we are replacing at certain intervals normal threaded rod suspension with channel suspension, which makes the whole system rigid. It forms a frame, so in the event of an earthquake, it can withstand seismic forces. So this is a real picture from job site. As you can see how it has been installed. An even clearer picture. The only difference is in rigid system, you replace your threaded rod with a channel frame so that it does not sway in the event of an earthquake. The challenge is these systems need to be installed during the time of installation of normal support itself to avoid any additional costs. This is an example of a channel frame. Now, what is a channel bracing system? Channel bracing system are similar to the rigid system which we saw earlier, but in this case we are strengthening it with additional channel bracing. Why? To make the system more stronger. Why do you need to be more stronger? It needs to be more stronger, especially when your service is far away from the ceiling. Let's say you have drop height of 2 meters, 2.5 meters, then the normal single channel rigid system might prove not to be safe. So thereby you need to additionally strengthen with additional components to make it more stiff. This is some real pictures from construction site on this application. So here also you have the same challenge. To avoid additional cost, you have to install these systems together with the normal support so that there is less uh, hassle and less you would save on the cost itself. Now the third solution is the opposite of 1 and 2. You can install the system even after completing the whole project. Even after you complete the complete electrical installation or mechanical installation, you can consider adding a seismic support. Now this system calls for a bracing system. So here you are utilizing the existing system, strengthening it with wires or threaded rods. So here, as you can see here, this is a normal system which existed, but you further strengthen it out with additional braces. So this bracing can be built with wires, as you can see here, or you using threaded rods. So these are some pictures of threaded rod bracings. As you can see here, threaded rod bracings again. This is a rigid system. Furthermore, examples of bracing system using threaded rods. And this is a glimpse of the calculation which would be submitted for approval. So based on various standards accepted by the project, we do the complete seismic calculation to prove that the application has been safe. And this is one example of a bracing system installed at site. What do we offer in seismic? We offer seismic anchors, normal and seismic supports for MEP, and we also offer the complete range of calculations and on-site demonstrations and trainings. In addition, I would love to show you uh, something interesting which we start working in recent times is the Fischer Modular system, wherein we design components. These are mainly applicable when you have typical construction like a tower. You can use it very effectively in a corridor location. So you mount all the MEP components to a channel frame designed and provided by Fischer, and then this channel frame can be directly very easily transported to the construction site from a factory, and it could be installed very easily. So Fischer Modular System comes with complete design support, complete on-site guidance for your end users. This is a factory where they were installing the modular systems, and we also do a random inspection to ensure that the modular factory, all the modules randomly has been checked and verified, and they are as per our recommended standards. So thanks a lot for your attention and your patience, because we had some technical difficulties. Before you leave, we would have around 10 minutes where we can interact. If you have any questions, please mention it in the questions tab so we can discuss further. Also, before you leave, please make sure to visit the poll button to rate our webinar experience. So we would look forward for hearing from you. Mr. Shuraim Ahmad Malik, can you further explain to us? Yes, Mr. Shuraim, a modular system is it's not a new technology, but it's a smart way where we mount all the MEP components in a corridor, let's say, in a factory. So the whole MEP uh, services which is required for a corridor is mounted to a frame. It could be 3 meters typically, it could be sometimes 2 meters, sometimes 1 meter. So basically everything is installed and connected, and then this particular frame, including the pipes, ducts, cable trays, are taken to the job site via a truck, and then it is lifted and it is just installed onto the ceiling. So thereby you save a lot of cost, because you can even start working for a floor before the casting of the floor has begun. So we have seen that you would save at least 4 times the time spent in in uh, uh, installation of MEP supports. So if you are further interested, we can share with you some details, some pictures for your reference. We would be happy to do that. I hope I was able to answer your question. Ladies and gentlemen, thank you very much for participating in today's webinar. I hope we were able to give some clarifications uh, and we were able to provide some value addition to you today. So we are looking forward to seeing you for our next webinar. So till then, stay safe and stay tuned with Fischer. Thank you.